This video will cover evaluating limits graphically. Prior to jumping into a visual example, let's review some limit notation. So we'll see three scenarios. So the first scenario, this first notation reads the limit of f of x as x approaches c, and then this little plus in the top indicates from the right. Okay, that plus is telling you that you need to approach that c value from the positive direction. Which translates to from the right, moving left. This second piece of notation says the limit of f of x as x approaches c, and the little minus, as you can imagine, is telling you from the negative direction. So we need to approach c from our negative direction, which again translates to from the left, moving right. So just a quick aside. In terms of positive and negative directions, imagine you have your number line with its origin. We have our positive numbers to the right and our negative numbers to the left. So when it says from this positive direction, we're coming from the right and we're moving towards that value c in a leftward fashion. And the parallel to that on the other side is if we're coming from this negative direction and we're moving towards some value c, that would be from the left moving right. Okay. This third, by the way, those two pieces of notation that we started with, both of these we will refer to as one-sided limits, because we are going to approach c from just one side. This last piece is going to be a two-sided limit. And the two-sided limit is going to require that you approach c from both the right and the left. And for this limit to exist, both the one-sided limits must reveal the same value. So it exists if the limit of f of x as x approaches c from the right equals the limit of f of x as x approaches c from the left. So when we evaluate these limits graphically, if we have to do a two-sided limit, we're going to have to actually break it down and do both a limit from the right and from the left and see if they match. If they don't match, we're just going to say that the limit does not exist. Now, when it comes to actually determining the value of the limit, what is it that we are looking for? Well, the question we want to ask ourselves is, let me just thin this out. As the inputs, which is usually the x variable, approach some value c, we want to ask, what is the y value of the coordinate that the function approaches? And the answer to this question is the value of the limit. So the answer is equal to the value of the limit. So essentially, when we are evaluating a limit graphically, as we approach that value that x is approaching, whatever the coordinate that the overall function is approaching, we're looking to determine what the y value of that coordinate is as we get closer and closer to that point. And then one last thing we want to keep in mind before we jump into the example that we can star here we are not concerned with what happens at x equals c, but rather what happens near x equals c. So we are just all about the approach to that c value, not what the function actually equals at that c value. Because we may run across some discontinuities in our graph, and that limit still may exist. So it's all about the approach to that c value. So let's jump over to an example. I have a piecewise function set up on Desmos. Let's say that we want to find the limit of this function as x approaches 4. Now, this is asking us to evaluate a two-sided limit. So when we do limits graphically, we want to check the one-sided limits to determine what the two-sided limit will be. So we're going to approach this thing from the right, and we're also going to approach this value from the left. Okay. And if it happens to be that both of these one-sided limits approach the same coordinate, then our two-sided limit will exist, and we will be able to determine the value of that two-sided limit. So to make things easy to view, I am going to add a movable point to our graph, so I'll call it a f of a, asking me to add a slider. I'm going to agree so that I can slide my point. Maybe you can see it moving around a little bit. I'm going to change the color so it's different from the graph itself. So let's make it blue. Then I'm going to label it so that we can see some numbers associated with that. And because we're looking for the limit around 4, or as we approach 4, I'm going to change the interval in which a runs between. So let's just do, say, 3.5 and 4.5. And we'll slow down the speed in which it moves, and we'll have it bounce back and forth. So where the point currently stands, we see that the x value is at 3.5. So what we're going to observe, by the way, let's just note that we're approaching this value 4 on the x-axis. Okay? So we want to pay attention to is when this point moves, as this x value of this coordinate approaches 4, we want to ask ourselves, well, what's happening to the y value of this coordinate? And as we get really close to 4, or even reach 4 in this case, what is the corresponding y value? That will be the answer to our one-sided limit. So let's pay attention to that. So as we run through this animation, we can see that as this point gets close to 4, it looks like our y value is getting very close to 0. Okay? So we're going to say that the limit of f of x as x approaches 4, and in this case, this point was coming from the negative direction, moving right. So this is from the left, moving right. So we're going to say that this equals 0. Now if I move this point to the other side, so now that it's approaching 4 from the positive direction, if we play through this animation, it will bounce back in a second. Okay, so now as the x values approach 4, what are the y values approaching? You can see that they're also going to 0. So because our one-sided limits were the same, we can say that the two-sided limit exists and its value is 0. Now let's look at one final example. Let's say that we want to determine the limit of f of x as x approaches 1. Again, we have to answer this two-sided limit question with a graph. So for us to do that, we are going to look at the one-sided limits and see if they match. Now you can see at 1, we have this big gap here. So as you could probably imagine, we're going to have an issue, but let's just see visually what's going on when we have points that approach both of those coordinates at the top and bottom. So I'm going to add in another point to our graph. We'll call it B, f of B. And we'll have this B coordinate on the other side of 1. So we'll have this thing range from, let's say, 0.5 to 1. We'll have A range from 1 to 1.5. We'll label this, and let's change the color here. And now that shows up. Okay. So we have both our points. So let's observe the limit of f of x as x approaches 1 from the right, so from the positive direction. So that would be our blue point. And as it approaches 1 from the right, moving left, let's animate that A. So we can see as the x values are approaching 1, what do the y values approach? That looks like it's approaching 2. So again, the answer to our limits is the y value of the coordinate we are approaching, or the function is approaching, as we trace along the function curve. So as we trace along the function curve and x heads towards the desired value, what is the resulting y value of the coordinate that we're headed towards? So as we approach from the right, we can say that the one-sided limit from the right is going to be equal to -2. I don't know if I said +2 earlier, but it should be -2. Now let's observe what's happening with our other coordinate. So we'll bounce back. Now as you can see, I'm actually going to slow this thing down. As the x values are approaching 1, what are the y values approaching? We can see that they're approaching some point that doesn't look very nice and easy, but let's say around 1.18. So as we approached 1 from the left, the y values were approaching 1.18. So as you can see, these 2 points are not equal to each other. Therefore, because the one-sided limits are different, the two-sided limit does not exist. Okay? So to cap off our video, when we evaluate limits graphically, observe the one-sided limits at that x value, or whatever the x value is approaching, and look to see if they are the same. Again, what are the values that you're recording for the limits? You're taking whatever the y value of the coordinate that the function is approaching. Okay, so we're tracing along our function curve, and whatever the y value of the coordinate we get to is, that is the value of our limit.